Welcome and hello. This is a video exercise in the HEC RAS controller. We're going to be adding steady state profiles to an existing steady state flow file, and we're going to be doing that in HEC RAS. In this exercise, we will build a steady state HEC RAS model, manually add two profiles, run the model, and then we will programmatically add hundreds of additional profiles and then run the model again. So this is going to be a way to demonstrate how we can use VBA code to modify the input file, the steady flow input file, and save a lot of time and effort. All right, so let's get started. We will not be using the HEC RAS controller class specifically for this exercise. However, this is the sort of task you would often use in concert with writing VBA code and the HEC RAS controller. All right, so I got my HEC RAS up. Let's go ahead and start by creating a new project. Navigate to where you want to save the project. Okay, right here for me, and I'll just call it project. And okay, and I need to say that the unit system here is going to be metric. And okay, yes. And let's open up the geometric data editor. Go ahead and sketch a river reach from upstream to downstream, and then give it a name. I'm going to call mine River A and Reach 1, and then click OK. Next, I'm going to add a couple cross sections. So click on cross section, downstream cross section, and an upstream cross section. I'm going to go Options, Add New Cross Sections. Start at River Station 0, and we're good to go. I am going to paste in some data here, station and elevation data for the downstream most cross section. And let me just add in some additional data here for the Manning's end values. The overbank appears to be at cross section 20 for the left and 60 for the right. So apply data. There's the cross section over there. Let's go ahead and make our upstream cross section now. So options, and then copy the current cross section just to speed things up. I will put this at River Station 1000, and I will say that 1000 downstream for the left overbank, main channel, right overbank. And I'm also going to increase the elevation here, but just by 1 meter because this is a 0.1% slope. So boom, there's that. Apply data and confirm that we have a downslope. All right, so let's close that up. I'm going to add a couple intermediate cross sections that will be interpolated just so it looks a little bit more normal. And then, yeah, you don't want to go 1,000 meters between cross sections. That's probably too long. Go to the tools menu, cross section within a reach. Here's our only reach. Let's go ahead and put them every, say, 100 meters. Interpolate and close. All right, there are our cross sections. Next, what I want to do is add the flow file. So that's all we need to do for the geometry file. I'm going to go File, Save the Geometry, and then we'll call this Base and Open. To add a steady flow file, go to Edit, Steady Flow Data. And then actually I also need to put in the boundary conditions. I'm going to go with the normal depth for my downstream boundary condition. And we know that the longitudinal slope in this reach is 0.001. That is 0.1% as a decimal, and okay. All right, so what I'm going to do next is add two flow profiles. We're going to run the simulation, and then the code that we're going to write in just a moment is going to increase that number. So we'll start with 2. That gives us a PF1 and a PF2. Let's go with 50 CMS and 500 CMS for the two different flows. File, save data. I'll just call it base and okay. All right, so we can close that. Let's go ahead and create a plan and then run it. So let's go up to Run, Steady Flow Analysis. We're going to go with Subcritical Flow. And then, yeah, it has our base geometry, our base steady flow file. So we can save this. We'll just call it base again. And then the short ID can be base and compute. Okay, that's done. Let's take a quick peek at the results and then finally get over to the VBA. So I'm going to go up to View and Cross Section. So this is the cross section at the top of the reach at River Station 1000. What we're seeing here is the water surface elevation and the cross section view of the first profile, which is 50 CMS. So 500 CMS is probably going to be a little bit higher. We can put them both on the screen at the same time. So let's just add that and okay. Yep. So up here is 500 cubic meters per second flow, and that's at that top cross section. Here are the other cross sections. Let's just focus on this top cross section at River Station 1000. We can also look at the water surface profiles. So we got both profiles in view here, 50 CMS and 500 CMS. And let's take a quick peek at the table data and then get going with the actual programming. Here is the data for the top of the reach. We have the 50 CMS row here, the 500 CMS row here, with other data such as water surface elevation, energy grade line, main channel velocity, and so on. But the main takeaway from this uh, part of the exercise so far is we only have two flow profiles, 50 and 500 CMS. Let's say, for instance, you wanted to add more. So if we were to do that manually, we'd go to Edit, Steady Flow Data, and then we would add a number here. Now it says the maximum is 32,000. So we're not going to be adding that many, but we are going to be adding about 400 or 450. So you don't want to have to type in 450 right here and then tab off and then populate all of the flow rates manually. I mean, you could, but we could also write a script to do the same thing. Also, we're going to rename these flow profiles with the actual number, so it's a little bit easier when looking at the plot. And I'm going to change this back to 2 before I forget. Okay, and that looks good. And I'm also going to save it just to make sure that everything looks good. In fact, let's go ahead and take a look at the text version of this flow profile before we head over to the actual VBA. We can get the VBA up and running just so we have something to look forward to. All right, so actually, you know what? I'm going to write this in sheet 1. Let me go back to my controller. So this is called controller.xlsm. And sheet 1, yeah, let's write the code in sheet 1. That is right here. And then, yeah, like I said, let's take a look at that flow file. Here is the project directory. Actually, it's in here. All right. And then what I want to look at is this project.f01. And let's open that in a text editor. This is the file that we are going to modify. We see in line 3 here, the number of profiles is 2. In line 4, we see the profile names are pf1, pf2. So this is just an integer. This is a string that is concatenated with or delimited by commas. And then the actual flow values are start down here in line 6. And it's 50 and it's also 500 for pf1 and pf2. Now the project file would probably tell us that this is units of metric. But what we also need to keep track of is the actual flow rates here in CMS are 8 characters and then 8 characters right here. What also may not be obvious, but I figured out through trial and error, is that every 10 flow profiles, you're going to have a new line break as well. So let's go ahead and start digging into the Visual Basic code. Here's my controller and Control V. I'm just going to paste in everything right now ahead of time and then explain what's happening. All right, so first off, we're going to be populating that existing steady flow file with 451 flow profiles ranging from 50 up to 500 with a step of 1. So instead of just 50 CMS and 500 CMS, we're going to populate it with 51, 52, 53, 54, basically all the integer values between 50 and 500, including 50 and 500. So update profiles is the call. We're going to be calling this main function. And then here is that value right here. We are reading in these 3 parameters, all of which are integers. I just made this function up. So there's a lot of room for improvement. There's a lot of potential flaws with this function, but this is just how I wrote it. It's not polished at all, but it's something to at least get the job done. All right, so we have minimum, maximum, and the interval. So if we wanted it to just step by 10, I could have put a 10 right here and be 50, 60, 70, 480, 490, 500, but we're just going to go with 1 just to kind of demonstrate the power of what can happen here. I mean, we could actually go 5,000, right, or 32,000, but I think this is a good amount. All right, let's start scrolling down here. Line text 3, 4, and 6. This is going to be the text that we're going to be inserting into the steady flow file. So we're going to be replacing the text here. This is going to say 451. This is going to be a long string of text that is the profile names, all 51 of them. And then right here, this is line 6. We're going to replace the values you see here with all the flow values between 50 and 500. All right. Next, the 3 box, line 3, line 4, and line 6 is where I'm defining that line text. So I have line text 3 is just equals to number of profiles equals profile count. The profile count is quite simply the difference between the maximum and the minimum plus 1. It should already be an integer, but I'm converting it to int anyway. Line 4 is right down here. What that is going to be is I'm looping from the minimum to the maximum, and then I'm going to use a comma separator, and then I'm just going to continue concatenating the names of those profiles, and I'm also going to append the letters CMS. So it's going to say 50 CMS, 51 CMS, 52 CMS, delimited by commas. All right, line 6 here. This is similar to line 4, where I'm just going to be printing out the numbers 50, 51, 52, except what this line does right here is it's actually going to add some padding to the left so that each of the numbers have a total of 8 characters. So instead of just 50, it's going to be space, 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 50, and then another 6 spaces, 51, 6 spaces, 52, all the way up to 99, and then it's going to have what 5 spaces, 100 for 100, 5 spaces, 101, all the way up to 500. Did I say that right? Okay, I think that was right. And then finally, the last part of the subroutine is to actually update that file. So this is the file path. In fact, this is something I think I need to update because this was from my preparation. I'm going to go to the file itself and then right click and copy as path. Okay, so let's go back here and paste. So I think that's correct. Project HECRAS project.f01. Okay. And then that file path is the first parameter sent to this other function that's down below, or a subroutine, excuse me. It's called update file by line. So we're going to update line 3, 4, and 5 with the line text 3, line text 4, and line text 5. And then the same file path is going to be passed each time. So we could have updated all 3 of these lines in the same subroutine, the same call, but I just decided to do it this way. Down below here, this subroutine, update file by line. There's no comments per se, but it does kind of what it says. It's going to update this file with this line number with this particular text. First, what I'm doing is reading the existing steady flow file, and then this lines here, this is a string array. So what it's going to do is each line of that file will be in a separate entry in this lines string array. And then in this line right here, we're going to update the text that we're passing in that lines string array. And then finally, at the very bottom, we are going to open up that same file for writing, and then we're going to print in the line to that file one line at a time. So let's go ahead and scroll up and just see if this works. Let's get that file up on screen. All right, very nice. I also need to save it. All right, and then let's go to run subroutine. All right, silence is success. Now, if I click over here, it should tell me that it actually has been updated in the background. Would I like to see the updated version of this file? And of course, the answer is yes. So I'll click on yes, and boom, this looks good. We have number of profiles, 451. We have the names of those profiles. This is line 3 and now line 4, 50 CMS, comma, 51 CMS, comma, 52 CMS. That should go, yep, all the way down to 500 CMS, separated by columns. Now, line 5, we actually did not change. That stays the same. Line 6 is the 451 different flow rates with that padding that I mentioned. So we should have 6 different spaces here. 1, 2, 3, 4, 5, 6, and then the 50, and then 1, 2, 3, 4, 5, 6, and then the 5, 1. And then once we get down to 100, which occurs right here, yeah, so we should have 5 spaces, 2, 3, 4, 5, 1, 2, 3, 4, 5, all the way down to 451. After that, the rest of the file just continues as it was before. It's been untouched by our program. So that looks good. That looks promising. I'm going to go ahead and close that for now. It's already been saved. Let's go back to HEC-RAS. In fact, to be safe, I'm going to just close HEC-RAS completely. And yeah, sure, save the file. Let me open HEC-RAS back up. Here is the project that we were just working on. Let's open up the steady flow file now, and hopefully we'll see the updates. So awesome, here it is, 451. And the other changes we made here are the names of the profiles. We can see 50 CMS, 51 CMS, 52 CMS, and of course below that the actual flow rates corresponding to that flow profile name, 50 CMS, 51, 52, 53, and so on. So if we scroll over to the right, boom, yep, 50 or 500 and 500. So that looks good. We could do some spot checks, 354, 282. All right. Let's go ahead and save this and run the simulation once again. So let's go ahead and save and then run steady flow. So yeah, everything is the same here. No need to change anything. Click on compute. Okay, took a little bit longer, but not too bad. And close. Now let's take a look at those same results we were looking at before. So let's go up to view and cross sections. All right, so now we have just a ton of different profiles loaded in here from 50 up to 500. We should see those reflected in this list of profiles from, yep, from 1 to 451. And it says the profile name over to the side. Very cool. And what else did we look at? How about the water surface profiles? Okay, so everywhere from 142 up to 147 for the water surface elevation. And lastly, let's take a look at the table data. Just taking a quick peek to make sure it's all there. Not really doing much in the way of analysis. So view menu, profile summary table, and then boom. Here we have, yep, all of our different flow profiles, starting with 50 CMS, 51, 52, 53, 54. So that makes it easy for us to grab the data we want by quickly adding hundreds or thousands of different flow profiles to our steady flow file using the code within VBA to update the text file used in the HEC RAS program.